Alright, question 72. It's a bit complicated, but I'm going to take it nice and slow for you. You start out with a function. They give you a function that goes from -3 to 3, and it goes as low as -1 and as high as +1. So this larger curve here is the original function f. Okay? And now they're going to do different things to the function, and you need to change your graph accordingly. So the first thing they do is they multiply by 3 on the inside. Normally you would think that would stretch it 3 times as wide, but since it's on the inside, it goes the opposite way. Instead of 3 times, it's 1/3 as much. So instead of going out to 3, it only goes out to 1. Instead of going out to roughly 1.7, it goes to about 0.6. So instead of going to -3, it goes to -1. Instead of going out to roughly 1.7, it goes to -0.6. So it's 1/3 of what it was because you flipped this number, and that's how much it shrinks or expands. B, you got that number on the inside, and again you got to flip it to know how much to shrink or expand, and that's 3. 1/3 flipped is 3. So here's your original graph from -3 to 3, and instead of going out to 3, it goes out to 9. Instead of going out to -3, it goes to -9. Instead of going up to roughly 1.7, it goes 3 times as far to roughly 5.1. Instead of going to -1.7, it goes out 3 times as far to -5.1. I estimated this. When you look at it, it's around 1.7 and -1.7. Alright, so then this one is going to do two things. It's going to move to the left one, and it's going to make it 1/3 as much. It's going to shrink. So first you start out with the original graph right here from -3 to 3, this one, and then it moves it over 1 unit, so -4 to 2. Instead of -3 to 3, it goes -4 to 2. It just moves over 1 unit. And now, instead of going from -4, it goes to -4/3. Instead of going to +2, it goes to +2/3, because you multiply it by 1/3. And again, here, this is roughly, what is this? This point out here moves to 1/3 of what it was. This point out here becomes 1/3 of what it was. D, this one is going to make it expand left-right 3 times bigger. It's going to reflect on the x-axis, and you're going to shift it up 1 unit. So 3 times bigger, here's your original graph of f, and 3 times bigger makes it goes out to 9 and -9. Okay, so that's that, and then negative is going to reflect it. Instead of going from below to above, it now goes above to below. And then you take the whole graph and bump it up 1 unit, and y is your final answer. The whole thing that was here goes up 1 unit. Alright. 74 is the greatest integer function. It looks like this when you graph it, or when you look at it in a textbook. That's what it looks like. And what it does is it takes any number that you plug into it and rounds it down. So if you plug in 0, you get y coordinate of 0. If you plug in 1/2, you get a y coordinate of 0. If you plug in 1.2, you get a y coordinate of 1. Plug in 2.7, you get a y coordinate of 2. So anything less than 1 is just 0. Anything less than 2 is just 1. Anything less than 3 is just 2. And so you get this guy here. Now they want you to graph 1/4 of the greatest integer function. Well, remember, that's going to make it 4 times longer. So instead of going out to 1, it goes out to 4. Instead of going out to 2, it goes out to 8. Instead of going out to 3, it goes out to 12. And same thing over here. So what did we do in this section? Vertical shift takes a known function and bumps it up or down so many units. A horizontal shift takes a known function and it puts a number on the inside of the function, subtracting or adding, and again it moves the opposite way you would think. Reflecting, a negative reflects it on the x-axis, and a negative on the inside reflects it on the y-axis. Vertical stretching and shrinking, it moves the way you would think. If the number's like 4, it's going to make it 4 times as high and 4 times as low. If it's 1/3, it's going to make it only go up 1/3 of what it was and down 1/3 of what it was. Perfectly normal. Again, vertical shifts and stretching and shrinking are normal. It's the horizontal that's weird. Horizontal, if you got a number like 3, it's going to shrink by 1/3. If you got a number like 1/2, it's going to make it twice as wide. So again, these work in the opposite way you would think.